Okay. So again, I'll just use the simplest possible examples, which is power functions. The integral from 0 to infinity of again 1 over x. Okay? Natural log of infinity is undefined. Again, if you go to the pictures of the exponential and natural logs, okay, you understand there's no limit on the exponential to how big the x can be, right? Even though if x gets big, these things get hugely tremendous, right? Exponentials grow very, very fast, okay? Well, that means that when you flip this thing around to this shape, you have to go a long ways out before the log gets very big, right? But just because there's no limit to the x values you can put in to the exponential function, there's no limit to the y values that you get from the logarithmic function. Now that's a statement you want to think about a little bit if you're inclined, okay? But that's how you reason out the fact that the natural log of infinity is undefined. The limit as c goes to infinity, a natural log of c is undefined because there is no limit to how big the natural log can get. Okay? Because of this picture, because of the nature of the inverse function, because of the behavior of the exponential function. Because you can put as big a number as you want into the exponential, your logarithm can get as big as you want. Okay? So we do the same thing with our definition. We just integrate from 0 to c, but we assume c is a great big number. And our picture that goes with that is, well, here's our graph of 1 over x. It gets very tiny, but it keeps going, and it gets tiny slowly enough, but it still accumulates unlimited area if you go far enough. Or as you go further and further, the area it accumulates is unlimited. So if this is 1, and this is c, okay? Let c keep getting bigger and bigger. You accumulate more and more area. And you have to do the integral to determine whether that actually works. You could do numerical calculations for the rest of your life, and you would never be able to establish that this thing approaches infinity. Okay? It approaches infinity, but very, very slowly. Well, anyhow, this then equals natural log of x evaluated between 0 and c, which is natural log of c. And it's not between 0 and c. I don't want to go to 0. I'm going to use 1. I could have done 0 to c, but then you'd have to do a limit at this end and at this end. Okay? And, you know, calculus students never remember to keep writing out the limit because they're tied up in the algebra. I did the same thing in calculus. Well, it appears that I'm doing the same thing now. Okay, so in 50 years, nothing has changed. But anyhow, Okay, its limit of C goes to infinity of all this stuff, and now my C's up here and my C's down here getting in each other's way, but anyhow, and this limit is infinite. Not because your calculator says so, because this graph says so. The inverse function relationship says so. Okay, so there we have it, other examples. We have this. Well, we can write out antiderivative of this. It's again right. But you can't evaluate at infinity. So we just say the limit SC goes to infinity, the integral from 1 to infinity, 1 to C of 1 over the square root of x dx equals the limit SC goes to infinity of 2 square root of x evaluated between 1 and C, which is the limit SC goes to infinity, I remembered at that time, of 2 square root of C minus 2 square root of 1, right? That's the limit of C goes to infinity of 2 square root of C minus the limit SC goes to infinity of 2 square root of 1. This is 2. That's perfectly okay. But this is undefined. Since it's undefined, there's no point in even writing out that negative 2. Okay? Well, actually, it's not undefined. This is infinite. This is negative 2, but that's just subtracting 2 for something that is unbounded. You know, 2 isn't a drop in the hat compared to something that's unbounded. Okay? 2 doesn't change. This keeps getting bigger. Make sense?
Yeah.
So the technique is simply, if you have an infinite limit on your integral, you have to do this. Okay? If you have an antiderivative that's not defined at this lower limit, you have to do this. And it's really pretty simple, just to get in the habit of doing it. So I would recommend that you take another look at the section on improper integrals. Please let me know if you have questions. Okay?
Yeah.
We'll arrange a time to meet and we'll talk about it.
Okay.
Okay, well, we still have 13 minutes of class left this semester. Do you have questions?